When we talk about making the massive global shipping industry greener, your mind probably jumps to things like new, cleaner fuels, or maybe even sleeker ship designs, right? But what if one of the most powerful solutions has nothing to do with how ships move and everything to do with how they stand still? Okay, let's dive into the surprisingly critical role of shore power in cleaning up our ports. So picture a busy port, the lifeblood of global trade. You see these giant ships, these absolute marvels of engineering, loading and unloading. But while they're just sitting there, sometimes for hours, sometimes for days, they're creating this huge, often invisible, environmental problem right in the middle of our coastal cities. So, what is this hidden source of pollution? It's not just the trucks or the cranes, though they're part of it, for sure. No, the biggest culprit is actually hiding in plain sight. Yeah, it's the ships. See, to power everything on board, we're talking lights, refrigeration for cargo, communication systems, the whole shebang. These vessels have to keep their powerful auxiliary engines running on marine fuel 24/7. They're basically acting like their own floating power plants, just idling right next to where people live. And this is not a small issue. The scale is, well, it's staggering. Get this, research shows that these ships just sitting at the dock can be responsible for anywhere from 55 to a whopping 77% of the total emissions in the areas right around the ports. That's a ton of sulfur oxides, nitrogen oxides, and nasty particulate matter just blanketing nearby communities. But what if there was a really simple, almost elegant solution to all this? What if ships could just, you know, plug in? Well, this solution has a name. Onshore Power Supply, or OPS for short. You might also hear it called cold ironing, which is a cool throwback term from the old days when ships had coal-fired engines that would literally go cold when they were in port. The idea is exactly what it sounds like. Connect the ship to the local electrical grid and let it shut down those polluting engines. And the difference is just night and day. On one side, you've got onboard engines burning heavy marine fuel. On the other, the ship is just quietly drawing cleaner power from the grid. This doesn't just cut greenhouse gases, it completely eliminates those local pollutants that are so bad for public health. Oh, and it gets rid of that constant low-frequency hum. So it's a win for the climate, a huge win for the communities living near the port, and honestly, a win for some peace and quiet. Now, you'd think with a solution this obvious, every single port would have this set up. But the thing is, the upfront costs are huge, so adoption has really been driven by a growing wave of regulation from governments all around the world. And you can actually see this regulatory wave building over time. It really started gathering steam way back in 2007 when California put out some pioneering rules. Then China followed with its own mandates in 2016, and now the pressure is truly global. The IMO is shooting for net zero by 2050, and this is a big one. The EU's new FuelEU Maritime Regulation is going to make shore power mandatory in major European ports by 2030. The push is on. But here's the catch. As simple as plugging in a ship sounds, turning that idea into reality is a monumental engineering challenge. This is definitely not like plugging in your phone. Just to give you a sense of the scale we're talking about, consider this number. Over 10 megawatts. That's how much power a single modern container ship can demand while it's docked. To put that into perspective for you, powering just one of these massive vessels is like lighting up an entire small town. So now imagine a busy port with, say, a dozen of these ships all docked at once. The strain on the local energy grid is just immense. So the hurdles to get this done are pretty significant. You've got the massive costs, both for the ports to build the infrastructure and for the shipping companies to retrofit their vessels. The local grids often need huge upgrades to even handle the load. Then you've got these technical headaches, like standardization. A European port might be on a 50 Hz grid, but the ship was built for a 60 Hz system. That means you need these big, expensive converters. And on top of all that, every type of ship brings its own unique set of problems to the table. This is especially true for ships like bulk carriers or tankers. See, unlike a container ship that just parks in one spot, these vessels often have to do something called line hauling. Basically, they scoot up and down the dock to line up with different loading equipment. One report from California's Air Resources Board explains that this would mean you'd have to plug and unplug a massive high-voltage connection multiple times during a single visit. That's a really complex and pretty risky process. It's a perfect example of why a one-size-fits-all approach just isn't going to work here. So all of this brings us to a huge strategic question. With all this money and effort being poured in, Is shore power actually a future-proof technology? Or is there a risk it'll be made obsolete by the next generation of green fuels? And that's a totally valid concern, right? If you're a port authority about to spend hundreds of millions of dollars, you have to ask, why build all this electrical infrastructure if, in 10 or 15 years, ships are just going to be running on clean ammonia or green hydrogen and can generate their own clean power while they're docked? Are you just building a stranded asset? But the research from places like CE Delft paints a really clear picture. First off, let's talk cost. Even when these new e-fuels become available, it will almost certainly be cheaper to just buy electricity from the grid than to burn that expensive new fuel to generate it on board. Second, local pollution. Shore power is a guaranteed zero at the source. Many of those future e-fuels, like ammonia, can still produce harmful pollutants like NOx. And finally, and this is key, shore power taps into the greening of our entire land-based electrical grid, instead of having to rely on a brand new, and let's be honest, currently non-existent, global supply chain for e-fuels. So, what this all really means is that shore power isn't some temporary fix. It's a foundational technology. It's the absolutely essential bridge that solves the urgent port pollution problem we have today, while also perfectly complementing the zero-emission fleets of tomorrow. It's not a stranded asset, it's a core piece of the puzzle for the future. Which kind of leaves us with one final thought to chew on. As we race to decarbonize the world's oceans, maybe, just maybe, the most critical connection we need to build isn't the one that crosses the sea, but the one between the ship and the shore.